This video is on normalization. Normalization requires understanding of two simple concepts, which are functional dependency and prime attribute type. So functional dependency occurs between two sets of attribute types of a relation. We have the attribute types X and Y. Functional dependency X to Y implies that value of X uniquely determines the value of Y, or Y is functionally dependent on X. Let's look at it from a different perspective. We have employee social security number that leads to employee name, and the dependency shows that the employee name is functionally dependent on the social security number. Think of it this way. X is the determinant and Y on the right is the dependent, and it shows the relationship between the attributes in the data table. So it basically means if you know their social security number, you can find their name. You can do this for multiple attribute types as well, like project to a combination of project name and product category to show that both attribute types are functionally dependent on the project, as well as social security number and project name to hours to show that hours is dependent on both social security number and the project name. Basically, you can get Y from X. Just think of it that way. Another concept to understand is prime attribute type, which is an attribute type that is part of a candidate key. For example, social security number or employee ID are prime attribute types that make up a key, while attributes like hours or names are non-prime attribute types and don't make up a key. Candidate key, or simply a key of a relational database, is a minimal superkey. In other words, it is any set of columns that have unique combination of values in each row, and with the additional constraint that removing any column could produce duplicate combination of values. Alright, now let's go over normalization, which is the process of minimizing redundant data for insertion, deletion, and update. There are different normalization steps to ensure all redundant data are fixed. We have first, second, third, BCNF, which is also 3.5, and fourth normal forms to consider. There's also fifth normal form, which is not as common. First normal form is focused on the domain constraint. It states that every attribute type has to be atomic and single-valued to ensure no composite or multi-valued attributes types exist. If it has composite or multi-valued attributes in the relation, it's called unnormalized, and it is not in the first normal form. A composite attribute type is something that can be further decomposed, like the address in this relation. Multi-valued attribute type is something that has more than one value, like phone numbers which someone can have. For composite attribute type, simply decompose the attribute types. To fix multi-valued attribute types, we simply create another relation. The new relation has a composite key, and it has a foreign keys related to the first relation. Let's go over second normalization form. Second normal form is focused on making the attribute types fully dependent on the primary attribute. If it's partial functional dependent, then it is not in second normal form and it needs to be normalized. Let's go over what full and partial functional dependency is to better understand this concept. It's considered full functional dependent if you remove any attribute type from X where it is X to Y. It results in dependency not being upheld anymore. We have social security number and project number that leads to project title. This is a partial functional dependency because you can remove social security number and you can still get the P title from P number. Number 2, on the other hand, has social security number and project number that leads to hours worked by employee on a project. This is full functional dependent because you can't remove either the social security number nor the P number, because to get Y, which is hours worked by employee on a project, you need both. Here's another diagram. We have X value of SID and subject, because those are both underlined. The legend at the bottom says the blue line is partial functional dependent because you only need SID to get S name and SP number. You don't need both the SID and subject. However, to get the score, you need the student ID as well as the subject. So that is full functional dependent. So as you could see in the top relation, we have social security number and project number as the composite primary key, with project title and hours being non-prime attributes. To normalize this in the second normal form, we're going to have to find if there's any partial dependencies. As you could see here, project title is partially functional dependent because it doesn't need to rely on social security number. So we need to take that out and create a new relation to have that in there. So as you could see in relation 1, we have social security number and project number still being there, and hours, because hours is still fully functionally dependent on both of them. And then in relation 2, we have project number, which is now the prime attribute type, and now the project title, which is fully functionally dependent on the project number now. Next, we have third normalization form. 3NF depends on a concept called transitive dependency. What we're trying to do is get rid of transitive dependency. Functional dependency x to y is considered to have transitive dependency if there is a set of attribute type z that is neither a candidate key nor a subset of any key of the relation, while x to z and z to y hold. Transitive dependency in a database is just an indirect relationship between values in the same table that causes a functional dependency. And by nature, transitive dependency requires at least 3 or more attributes. Let's talk example. In a relation producer that has the attribute types name, code, location, address, product name, and serial number, let's mark name and code as primary attributes and everything else is non-prime. If serial number depends on a product name that depends on the producer name and code, then we have transitive dependency. And to normalize it, we simply need to ensure no non-prime attribute types are transitively dependent on the primary key. Here's a diagram example. As you could see here, job class is dependent on change hour, and change hour, as you could see, is partially dependent on imp number. So job class is transitively dependent on the imp number. We can't have a non-prime attribute be dependent on another non-prime attribute that is dependent on a prime attribute. So we need to take that out and create a new relation. All right, let's take a look at this example. We have relation with social security number, name, p number, and p name. As you can see, social security number is the prime key. However, in this scenario, we have p name that is dependent on p number, which is also dependent on social security number. If there's a non-prime attribute that doesn't belong in that relation and can exist without social security number, then we need to create a new relation by taking that out. So in R2, we have p number and p name, where p number is now the prime attribute in that relation, with p name being the non-prime attribute that depends on that. And then in relation 1, we still keep the p number, but we keep it as a foreign key. Next, we have BCNF, Boyce-Codd normal form. And this is considered to be 3.5 normalized form and depends on trivial functional dependency. Every relation in BCNF is in 3NF, but not the other way around, and is considered a stricter version of 3NF. X to Y functional dependency is trivial when Y is a subset of X. If there is non-trivial functional dependency in X and Y, where X is the superkey, then it is already normalized per BCNF. Simply put, X can't be a non-prime attribute. For example, SSN name to SSN shows Y is a subset of X. And you can make SSN and name a superkey. So this is already normalized. Next, we have fourth normal form. This is based on a concept called multi-value dependency. There's multi-value dependency from X to Y, where X points at Y if and only if each X value exactly determines the set of Y values, independently of other attribute types. It's in 4NF if it meets BCNF, and for every one of its non-trivial multi-value dependency, where X to Y, X is a superkey. And lastly, we have the fifth normal form, also known as the projection joint normal form, and this is the final normal form for removing any redundancy in the database. This normalization isolates semantically related multiple relationship by removing every non-trivial joint dependency.